Today I'll talk about feature selection. It is part of my series of lecture on machine learning. Feature selection is also known as dimensionality reduction. It is the selection of lesser number of features for machine learning to reduce computational cost and to improve model accuracy. What are the benefits of feature selection? Feature selection reduces computational cost. It reduces cost of further data collection. It results in better model with better accuracy, and feature selection improve interpretability of the model. These are the various methods for feature selection. One is filter method. Here features which are better associated or better correlated with outcome target are filtered out. It is done prior to feeding data to the model. Wrapper method. Here feature selection is done along with the model algorithm. It is done side by side. Embedded method. It is also along with model algorithm, but here only subset of features are tried at a time. So various subsets of features are tried at a particular time in embedded methods. These are the various techniques for feature selection I will cover in my lecture. Dropping of features with low variance, pairwise correlation, which I have covered in multi-collinearity problem and variance inflation factor. Correlation with target variable, I will cover this. Then correlation using R regression. It is a library in Scikit-Learn. Use of chi-square test for feature selection and use of chi-square test along with select k best from Scikit-Learn. Then I'll talk about information gain, mutual information in classification problem. And I'll use this in combination of select k best. I will not talk about information gain, that is mutual information in regression problem. Then I'll talk about use of extra tree classifier. Then I'll illustrate the use of recursive feature elimination. Then I will illustrate the use of recursive feature elimination CV to select the desired number of features. Then I will illustrate the use of sequential features selector. So let us go to our Jupyter notebook. This is our Jupyter notebook for feature selection. These are the libraries, initial libraries. These are general libraries for using in this notebook. First of all, I load the data. Data is on platelet indices. It is to test the hypothesis that platelet count and platelet indices are correlated with the coronary artery disease. So the outcome variable is coronary artery disease, abbreviated as CAD in this data set. This is our outcome variable. And there are certain input variables in this data set. This is the information of data set. There are some null values in this. So the prerequisite for feature selection, various methods of feature selection is that there should be no null value and there should be no string values. So these are the features which, these are the initial features which are considered, and then we will select from these features the desired number of features or the appropriate number of features. The variables that considered here are age of patient, BMI of patient, hypertension, whether present or absent, this is categorical variable, platelet count, mean platelet volume, platelet distribution weight, platelet large cell ratio, HbA1c values, serum cholesterol, triglyceride levels, low density lipoprotein cholesterol, high density lipoprotein cholesterol, duration of diabetes mellitus. Actually, the subjects were diabetic subjects in our study. This is gender of patient, then whether patient is smoker or not. This is again a categorical variable. And finally, there is the outcome variable known as coronary artery disease, whether the coronary artery disease is present or not. So first of all, we will remove the null values. So I will use the command as data frame dot drop NA. Then this is the information of data frame after deleting the null values or row with null values. Then now there are 378 rows in total with these variables. I have divided the variables into outcome variable or target variable, data X, which is coronary artery disease, and these are the feature variables or the independent variables. Now, this is the information about the feature variables. This is information about uh, the number of null values in the feature variable. Then this is about the number of null values in the outcome variable. So there are no null values now. Then first method is dropping off features with low variance. So this is the general command for calculation of variance. Uh, so these are the variances. So there are low variance. For example, for smoking, there is low variance. For gender, there is low variance, and there is high variance for cholesterol and high variance for platelet count. In fact, there are certain categorical variables here like smoking and hypertension. So variance is not clearly defined for those categorical variables, but they are listed here. I will use the variance threshold library from Scikit-Learn feature selection, and I will set the threshold to a variance value of 10. So all the variables which have variance more than 10 will be selected. So this is the command for variance threshold, and these are the features with low variance. So these will be omitted from the data set. And this is our data set, the features which are selected having high variance. So these are the variables which have high variance. Now, pairwise correlation, it is done to detect the multicollinearity. It is not a very good marker for multicollinearity. Instead of pairwise correlation, we should use variance inflation factor. This has been covered in my previous lecture. Now let us go to another method, that is correlation with target variable. Here we use the combination of data frame where the outcome variable is combined with the feature variables, and we will use the correlation function or CORR function of data frame to get the correlation of the combined data set. And this is the heat matrix. So this last row of this heat matrix is our correlation with outcome variables. So these are the feature variables, and these are correlated with outcome variable. So these are the high correlations. This is high negative correlation, and these are the low correlations. So I have filtered out the correlation with the outcome variable. Then this is my command for uh, filtering out the variables which are having R value of more than 0.01. Here I've used the absolute function. So these are the variables which have correlation more than zero point 0.1 plus minus zero point 0.1 with the outcome variables. So these are the desired feature variables. Then again the correlation using R regression function of Scikit-Learn feature selection. It is present in the newer versions of Scikit-Learn. So again, by using this code for finding the correlations more than 0.1, these are the variables. So the result is very similar. Uh, if we do it using the core function of pandas, or we use the R regression of Scikit-Learn, the result is similar, though same variables are selected in both the cases. Then use of chi-square test to find association between target variable and feature variable. Here prerequisite is that the target variable should be categorical as well as the feature variable should be categorical. So these are the three categorical variables in our data. So we will use only these three, and we will find the chi-square test value between these three variables and our outcome variable. So these are the p-values. So this is the only p-value which is significant in chi-square test. Then I will use the chi-square test with select key best function from Scikit-Learn. So this will do everything for us. In this will work, select k best will work along with this score function here. I have selected it as chi-square. And so only the hypertension variable is significantly associated, and this is selected out of these three categorical variables. Then the another method is information gain, that is mutual information. In classification problem, I will use the library mutual info classif of Scikit-Learn feature selection. This is the code for it, and these are the values. So I will sort these values in the descending order. So highest values are for these variables. So we can select these, and this is the bar graph of these. So high values are for initial these three very high platelet distribution with mean platelet volume, platelet large cell. So these are platelet indices. So they are very much uh, associated with the outcome variable, and these are the other three which are also associated with the target variable. Then we can use this mutual info classif along with select k-best, as we have used select k-best along with chi-square previously. So here score function is mutual info classif, and these are the variables which are having association with the outcome variable, that is platelet count, platelet indices, and cholesterol. Then there is something known as information gain, that is mutual information in regression. So our data set has an output variable which is categorical, so we cannot use this. Although the use of mutual info regression is very similar to mutual info classif, and that can be used for the problems where the outcome variable is continuous variable. So I will not illustrate this because in my data set, the outcome variable is the categorical variable. This is very important that our variables are categorical or continuous variables when we use all these methods. Otherwise, the result will be very vague. So now use of extra trees classifier, it is part of sklearn ensemble methods, and these are the codes. So we will extract the feature importance from the model, that is extra trees classifier, and these are the uh, variables in and the information, that is importance, is listed in descending order. So these are very important, platelet indices and platelet count, and this is the graph for same. It is very similar to our previous graph. Now let us come to the recursive feature elimination. This is used along with our algorithm. So algorithm, in this case, we will use logistic regression. So we will use recursive feature elimination along with logistic regression to select 5 features. And we print out the support. So this is the result. That is, this is the support, and 5 variables have been selected. And these are those variables. So hypertension, these are platelet indices, and HbA1c. These are the top 5 variables which are identified using recursive feature elimination method. Then I will illustrate the use of recursive feature elimination CV. Here we need not specify the number of variables. It will identify the desired number of variables. It will identify itself how many variables we need to select using the cross validation technique. So this is the code for recursive feature elimination cross validation. Here the estimator is logistic regression, like before in previous example. We will set the cross validation to integer 5 and step 1. So these are the results. So these variables are, it identified that there are these many variables, that is these 7 variables which are important. Previously we were identifying 5 variables, and that 5 integer we set was very arbitrary number. Now it has selected that there are 7 variables which are important. So it include BMI of patient, hypertension present or not. These are platelet indices, then HbA1c level, and smoking status. Then finally, I will illustrate the use of sequential feature selector. And here we need to specify whether we will use forward or backward method for selection, and forward method is default method. So I have not specified here. I have specified the number of variables to select that. I have set it to integer 5. And this is the code for sequential feature selector. And it works in combination with the model algorithm. And here I use logistic regression for that. And these are the features which have been selected. That is BMI of patient. These are platelet indices and smoking. These are top 5 variables. So these are the various techniques for the feature selection. And this is all for today. Thank you very much.